Arithmetic and geometric sequences. Here we go. Alright, there's lots of different types of sequences, but there's two different types of sequences that we're going to deal with, at least for right now. And they're pretty common sequences. The first one is called an arithmetic sequence. An arithmetic sequence is a sequence in which the difference of consecutive terms is constant. These are sequences where we're adding something repeatedly, maybe we're adding 5 to each term, or we're subtracting something repeatedly, maybe we're subtracting 0.3 from each term. Okay, those are called arithmetic sequences. The difference between each term is called a common difference. So for example, in the sequence 25, 50, 75, we add 25 each time. We would say the common difference was 25. Common diff was 25. All right. Now, we say common difference, but it can obviously be a positive number or a negative number. If we label these terms a sub 1, a sub 2, a sub 3, then the common difference, we're going to label that d. Common difference d would equal a sub 2 minus a sub 1. Or you might even say more generally, a sub n minus 1 minus, a sub n minus a sub n minus 1. Okay, so take the second term minus the first term. If we know if it's arithmetic, then that subtraction will give me the common difference. All right, let's move on. Okay, here's a rule for arithmetic sequences. The nth term of an arithmetic sequence with the first term a sub 1 and common difference d is given by this formula. All right, so in this is the nth term, right? The nth term, and this is the first term. This is n. That's an index. It's the same n over here. So if I plug in a sub 15, n is 15. And then d, like we said on the last slide, is the common difference. All right? So, for example, suppose the first term in an arithmetic sequence is 2, and the common difference is 3, right? The rule for a sub n. Well, before, we may have had trouble with this because we would have maybe been able to kind of write out some terms and we've done some guess and check. But now I can just plug it into my formula. I need two things to write a rule for an arithmetic sequence. I need the common difference and I need the first term. I have those two things, I can write an arithmetic sequence. Remember, this rule is going to behave like a function. So we're going to have n is going to be kind of like an x if we thought about it in function terms. So a sub n equals a sub 1. That was 2 plus n minus 1 times d. Well, d we said was 3. Okay, and now we should probably clean this up a little bit. A sub n equals 2 plus 3n minus 3. And so I think I get that the rule is actually 3n minus 1. Okay, and that's how the most basic use of this formula is. All right, let's move on. Okay, write a rule for the nth term in the sequence, then find a sub 15. So remember, I need two things to write a rule for an arithmetic sequence. I need the first term, and I need the common difference. Well, a sub 1 is given to us. It's 4. And the common difference d, well, remember we said that would be like if we took a sub 1 and a sub 2 and subtracted the second from the first term. So that would be like if we took 9 minus 4, that would give us 5. Okay. So our common difference is 5. So when I plug this into my rule, I'm going to get a sub n equals 4 plus n minus 1 times d. Okay, and then let's distribute and simplify here. So I think I'm going to get 5n minus 1. Let's check, does that work? If I plug in 1, I should get 5 minus 1, which is 4. Good. If I plug in 2, I should get 9. And I do it. So this thing works. And then I can go find a sub 15 pretty easily. 15 equals 5 times 15 minus 1. See, 75 minus 1, so 74. Okay. And that's a pretty basic application of the formula. Let's do one that's more complex now. Alright, suppose two terms in an arithmetic sequence are a sub 8 equals 21 and a sub 27 equals 97. Find the rule for the nth term. Remember, I said I needed two things. I need the common difference and I need the first term. Here I have neither one of those. So I think this is a situation where we're going to have two equations and two unknowns. So let's get started here. we said a sub 8 equals 21. Well, that means that if I use my formula, this formula up here, that a sub 8 equals a sub 1, I don't know that, plus, now I'm going to use that fact that the index, that 8, is n. And so I'm going to plug in 8 minus 1 times d. d I don't know, so I've got two unknowns. Let's go look at a sub 27 then. a sub 27 equals the first term, which I don't know, plus n, well that was 27, minus 1 times d. d was, oh yeah, we don't know it. Okay? Now I've got two equations, two unknowns. You can, oh, we need to make one adjustment, I'm sorry. I'm going to erase, so I don't have to rewrite everything. But a sub 8, we know what that is. a sub 8 is 21. Okay? Yeah, so sorry, before we had like four unknowns. And I also know that a sub 27, I can put a value in there, is 97. All right? So you might rewrite that step out in your notes, okay? That a sub 8 equals that, and then we know a sub 8 is 21. Now I've got two equations, two unknowns, so I should be able to make substitutions from here, okay? Excuse me, let's simplify each equation here quickly. We could use elimination or substitution. I think substitution is going to be easiest. So we'll take a sub 1 equals 21 minus, let's just write, instead of this piece right here, that's actually 7d, right? 7d. So let's go 21 minus 7d equals a sub 1. And then what I'm going to do is take this right here, this 21 minus 7d, and I'm going to plug it in right there in for a sub 1. So I get 97 equals 21 minus 7d. And let's agree that 27 minus 1 is 26, so this would be plus 26d. And now let's solve this thing for d. So I get 97 equals 21, let's see, minus 7 plus 26 is plus 19d. And then minus 21, let's see, that's 76. What was it? 19d. All right, and then 76 divided by 19 is 4? Yeah. Okay. So d is 4. And now I just have to go find a sub 1. Well, this shouldn't be difficult at all because I know d now. So I'm going to go back over to this equation that I solved for a sub 1 and plug in 4, which we should be pretty good at by now. 21 minus 7 times 4 equals a sub 1. 21 minus 28, so a sub 1 equals 7. And we could check, but finally our rule, oh my goodness, I kind of didn't leave myself enough space here, but my rule, right in this pink box here, is going to be a sub n equals, let's see, a sub 1 was 7 plus n minus 1 times d. Well, that was just n minus 1 times d, and d was 4. And you can simplify that if you want. But that's it. That's how we found a rule for a sub n given two terms in the sequence, neither of which was a sub 1, and without knowing the common difference. So we can use two equations, two unknowns. And now looking at this looks terrible. But hopefully you kind of followed along, and hopefully you're okay on this one. So let's move on to the next slide here.